We're going to come to an end of the opening ceremony, and I'm going to, in a few minutes, welcome Professor Andy Haines, who's going to be our first keynote, which is a real pleasure for me. But just in closing of the opening ceremony, we do have a welcome reception later on this evening for drinks, and Gaudiamus will be there doing offering to teach some short lessons on how to do this. So please have a little drink and a little nibble, and then get into some folklore dancing. So we look forward to seeing how that goes. And I think Neville Owen will obviously lead that, so good luck with that. So just before I do introduce Andy, I just want to finish by saying I'm not going to get another chance, so you'll be pleased about that, to get up on stage. But just to say a huge thank you, and it's been a real honour to be the president of the Society. Personally, I've really enjoyed it. It's been quite a lot of more work than I anticipated. I've been on the EC since Austin, and so it's quite a good time for me to get off now. But it has been a real honour and a real pleasure to serve the Society, and I hope that we've left it in a better position than we have, or at least kept it in the same position. I think we're in a very good position financially and strategically. So and it's been a real pleasure to work with the EC, in particular Antonio, who's our executive director, with Venue West and everyone else, but also to receive the support of all the members that I've had thus far. So it's been a real pleasure. So thank you very much. So, thank you. Thanks. Thank you very much. So it's also another pleasure of mine. I actually dobbed myself in for this job as well. So because it's a real pleasure and an honour to welcome Sir Professor Andy Haines, who's going to be our first keynote. And given that we are looking at healthy people, healthy planet, Professor Haines is a world expert in health and climate change co-benefits. And I visited him at the London School of Hygiene and Tropical Medicine some years ago, or 4 years ago. And he was very gracious with his time and gave me a lot of time to talk about issues that I was interested in, and introduced me to his group and other members. So it is a real pleasure for me. So Andy's a professor of environmental change and public health at the London School of Hygiene and Tropical Medicine. I promised I wouldn't say a lot because he said he would introduce himself. But he is an international world leader in this space. I know that he's led a Lancet Special Edition on health and climate change co-benefits. He's worked, consulted with the WHO on this topic. He's been a member and chair of a number of national and international panels and bodies. And so it's a real pleasure and an honour to have him here today. So please welcome Professor Andy Haines.
Well, it's an enormous pleasure and a privilege to be here this evening to be talking to you. Thanks so much to ISBNPA for giving me this honour. I wish, though, you hadn't put me after the folk dancing, because that's a tough gig, and I'm not sure that I'm going to be as wonderful as they were. But what I'm going to talk about really is how we're confronted with multiple changes which really are transforming our planet. And let me first of all start with this slide. I don't expect you to read the detail, but what I want to show you really on the one side, on the left side, is the signs of socioeconomic trends of human progress. And we've gone through an extraordinary period of human progress over the last 5, 6, 7 decades or so. We've seen life expectancy dramatically increase by about 25 years, something like that, since the middle of the last century. We've seen infant mortality fall by about 3/4. We've seen maternal mortality also decline. And when you read a lot of global health papers, researchers and policymakers, they kind of assume that the future will just go on like the past did, and we can just extrapolate, and that's where we're going to be in 30, 40, 50 years' time. But for better or for worse, that's, I don't think, the way things are going to work out for humanity. You can see on the left then the world population has increased dramatically. The world economic growth has accelerated. We've seen dramatic increases in the use of fresh water, of paper, of a whole variety of other resources, and human population is now well over 7 billion. So it's been a story of great progress, but at the same time there have been big costs, and the costs, of course, have been borne by the Earth's systems. And you can see those on the right side of this slide. So we can see carbon dioxide is accumulating in the atmosphere. It's the longest-lived greenhouse gas. About 20% of the CO2 that we put up in the atmosphere remains there for 1,000 years or so, unless we can find a way of easily getting out, which we don't have at present. Other greenhouse gases like methane and so on also are accumulating. We're overexploiting fisheries. About 90% of them are fully or overexploited. We're seeing dramatic transformation of many coastal ecosystems caused by the inflow of nitrogen and phosphorus from fertilizers, which is dramatically reducing biodiversity. And our oceans are also becoming much more acid as carbon dioxide dissolves into the ocean. So all of these dramatic changes have led to some people calling our era the Anthropocene. The term was first coined by Paul Crutzen, the Nobel Prize winner, in 2000. And the name really, as it implies, signifies the dominance of one species, that's our species, on the global landscape. So we're losing biodiversity at 100-fold greater than pre-human times. So we're driving many other species to extinction. This is just one of the pieces of evidence. This is the change in surface temperatures since 1850, when we've been keeping records. We can also look further back than that into ice cores to look at the atmospheric composition of the trapped atmosphere of the Earth many hundreds of thousands of years ago. But this is the more recent figure, and you can see that there's been a pronounced increase in temperature, a global average temperature of about 1 degree, according to these three separate but very closely correlated measurements of change in surface temperature. And it's that rise in temperature which has caused increasing concern, because we don't know how far and how long that's going to go on for. And I think there's no doubt now that that increase in temperature is due to, first of all, it's real. Secondly, it's due to human activities, largely because of the emission of greenhouse gases from fossil fuel and other sources. This shows you the emissions projections for over the last few decades, and you can see that a couple of years ago we thought emissions were going to plateau off. But in the last couple of years, they've gone up again. So that plateauing was unfortunately not real, and we're accelerating again. You can see traditionally it's been the European countries and the USA that have benefited from fossil fuel powered development, but other parts of the world, like China, for example, which has accelerated in the early 2000s, but is now plateaued off, and India, of course, which still has quite a long way to go before it reaches our per capita emissions. So that's where we're going at the moment. Unfortunately, we need to do much better. We need to cut emissions quite dramatically. What's the fate of all these anthropogenic carbon dioxide emissions? Well, the sources on the left side slightly exceed the sinks. The sinks are the atmosphere, trees and vegetation, and the oceans. And you can see where the carbon dioxide goes in these three different sinks. But the important thing is that the sources exceed the sinks by about 5% a year, something like that, by about nearly 2 billion tons of CO2 per year. And it's that increase which is powering climate change, together with these other gases called the short-lived climate pollutants, like black carbon, for example. It's that black particles when you're going behind an old diesel bus or whatever it is. You look at the exhaust, you see those black particles, that's black carbon. So they're obviously an air pollutant, so they damage our health, but also they heat the atmosphere, and when they land on ice, they accelerate the melting of ice. Methane is an important greenhouse gas. It only stays in the atmosphere about 12 years, something of that order. It's also increasing. It comes from a variety of sources, including ruminants, sheep, cattle, for example, from rice paddies, from gas leaks, and a few other sources as well. And then ozone is a secondary pollutant. It's formed from methane and from other precursors in the atmosphere. It's also a greenhouse gas. It's also toxic to humans. It also has effects on human health. Probably kills several 100,000, maybe up to 1 million or more people a year, something of that order. So where are we going at the moment? Well, this is essentially shows us two different futures, really. So the bottom line, the kind of bluish line, is what would happen if we could really cut emissions back very drastically, and we could stay below 2 degrees. 2 degrees is it's the level that most climatologists think we need to remain under. And they think that if we can keep below 2 degrees, that will reduce the risk of extreme events, such as collapse of the Antarctic or Greenland ice cap, for example, and other major extreme sudden shifts, state shift events, which could propel humanity into a much more hazardous future. The upper line is business as usual, and that would take us to about 4 degrees warming. Now, that's not uniform, because when you warm the planet, the oceans warm less than the land, so the land could warm 5 or more degrees by the end of the century. Where are we now? Well, after the Paris Treaty, many of us felt quite elated. There was a political agreement. It was a great political triumph. But we're now seeing that treaty being undermined by the activities of the current US government and possibly other governments as well. And even if those treaty agreements were implemented, we would still be somewhere between these two. So we'll be somewhere around 3.2 degrees warming by the end of the century. So much higher than we can be comfortable about. And as I've said, this is not uniform warming. So even if we get to 1.5 degrees, which we could get within a couple of decades, something of that order, then events which occur every 5 years now, like hot years, for example, would be every 2 years, or by the time we reach 2 degrees will be almost every year. And you can also see that warming is increasing more at the poles than it is closer to the equator, but of course close to the equator, people are living much closer to the edge of what you can tolerate in terms of extreme heat. So how do the risks increase with temperature? Well, here we see a summary from a recent IPCC report, and you can see how as the temperature increases above 1.5, 2 degrees, the risks increase to ecosystems. So ecosystems can't keep pace with the speed of climate change. Some species can't migrate fast enough. You get flooding of coastal regions because as you warm the oceans, they expand, of course, and sea level rises. More river floods due to intense precipitation. Crop yields decline. Coral reefs die off, and indeed they're already showing a lot of die-off. And the Arctic region, as I've already shown in the previous slide, is subject to accelerated warming. So the risks increase as the temperature increases, and there may be thresholds which trigger these kind of irreversible and sudden changes. It's not just temperature, of course, it's also precipitation. So this slide shows you where there might be increases in precipitation, the blue areas, or decreases. So you can see around the Mediterranean, for example, decreases in precipitation, southern Africa, parts of Latin America, including over the Amazon, much of the US, and much of Australia. So it's a combination of temperature and precipitation changes. The temperature's easier to model than the precipitation. What sort of effects can it have on health? Well, there are a whole range of effects, and I'm not going to go into detail with all of them because there are whole conferences now on health and climate change, but I'll just mention a few. You can see that there are a number of mediating factors. So obviously, rising temperatures can lead to more heat exposure, more heat-related deaths. Changes in vector ecology can change the distribution of diseases like dengue or malaria or some of the tick-borne diseases. You can increasing allergen exposure and longer allergenic exposure, longer seasons, pollen seasons, for example. Changes in water quality leading to water-borne diseases, undernutrition, of course, injuries, fatalities, and heat-related illness. And then finally, that category which is shown here, which is the most difficult to model, the most uncertain, but also very, very worrying, which is the potential of climate and other environmental changes to lead to forced migration, civil conflict, and have wide-ranging effects on mental health that I'll mention briefly later on. Of course, as I've said, temperature increases are not uniform. Those of us who live in cities are likely to be exposed to higher levels of heat because of the urban heat islands. So the urban environment absorbs heat, it radiates heat again at night, and of course that raises the temperature of the city. But it depends very much on how much green space we have and how much blue space we have and what kind of surfaces we have in the city. So you can paint buildings white, and that helps to some extent to reflect some of the heat. Some of the extreme events that we've seen in the past, like the European summer heat wave of 2003, which killed probably around 70,000 people in all, are likely to become the norm over coming decades, as shown in this slide. And in that dramatic heat wave, the people who died, obviously there was preponderance of elderly people, people living alone. But it wasn't just elderly people, it was also people who are comparatively fit because of the extreme levels of heat. And many of them, as shown in this book here, were socially isolated people who didn't have access to air conditioning, who often lived in the top floor of buildings and they couldn't easily escape. And there were no systems in place to rescue them from the intense heat. But it isn't just heat-related death. Heat has all sorts of other effects. This slide shows you how the ability to undertake physical activity declines over time. So this is the estimated loss of labour capacity over the last couple of decades or so, as estimated by colleagues in the Lancet Countdown. And on the right side here, we see the spread of really intense heat. This is the kind of yellow area here. Intense heat increases in its area as the world warms. So when you get to 2.5, 3 degrees, then over 1 billion people would be exposed to this heat, and that would be sufficient to pretty well prevent them working for the hottest month of the year. Many of those people would be poor labourers, subsistence farmers. They can't work in air-conditioned factories, and they would be driven further into poverty. But of course, climate change also has implications for some of the work that you do. It's not just physical labour, of course, it's also physical activity for the purposes of sports and so on. This interesting paper by Kirk Smith and Alistair Woodward and others a couple of years ago in the Lancet modelled the likely last summer Olympics in the Northern Hemisphere. They just restricted their analysis to cities in the Northern Hemisphere, cities that were large enough to theoretically host an Olympic Games. And what they said was that if we go down the high emission path of greenhouse gas emissions, that later in the century, there are going to be very few cities left. These cities, the green bars here, very few cities where you could actually host a Summer Olympics because it would be physically hazardous to exercise, particularly the distance events, because of the intense heat. So it would only be a relatively small number of cities in Western Europe and a scattering of cities in other parts of the world where you could actually hold a Summer Olympics without putting everyone into air-conditioned arenas or whatever. So that's a kind of indication, really, of the rate of change that's occurring in the climate. Of course, we could stop that. We could reduce emissions. I'll come back to that later. This is some work not done by me at all, but done by colleagues Obradovich and Fowler, Nature Behavior Change, a couple of years ago, where they looked at the data on reported participation in recreational physical activity for nearly 2 million US survey respondents over the last decade or so. And they showed that both extremely cold and extremely hot temperatures reduce physical activity, as you can see here. So on the right here, you can see by age, and you can see it falls quite dramatically in older people. And they also looked at people who were overweight and obese. And again, you can see this rapid decline at higher temperatures for people who are obese, and to some lesser extent, those who are overweight as well. So in the case of the US, they suggested that there could be quite a shift in the capacity of people to exercise with climate change. And towards the middle and then the end of the century, you can see that in the colder areas, in the winter months, you might get more physical activity. In the summer months, particularly in the south, much less physical activity. So it becomes progressively more difficult to exercise. And of course, most of the world's population lives in these kind of areas or much hotter areas. So for most of the world population, it becomes more and more difficult to undertake any kind of vigorous physical activity as climate change goes on. But it isn't just the direct effects of heat, of course. There's also the effects of climate and other environmental changes on nutrition. This slide just shows you the impacts of climate change on the productivity of food crops in 2050. The red area is where we're going to likely see declines in productivity, and the green where we may at least temporarily see increases. And you can see that the green is mainly in the temperate regions. Of course, they are often the regions that have contributed most to climate change, and those that have contributed least, sub-Saharan Africa and South Asia, are subject to the highest levels of heat exposure and the potential reduction in crops. So you can see that there's a big overlap with the global hunger index as well. There have been a number of studies looking at the climate change impacts on food and nutrition. This is just one of them, published in The Lancet a couple of years ago, when they looked at the likely effect of climate change on reduction in global food availability. Overall, a few percent, but as I've said, it would vary dramatically in different parts of the world. So for some parts of the world, it would be much, much more than 3%. It would be, 10 or more percent. So it could really have a dramatic effect on undernutrition. And they suggested even making relatively conservative assumptions, possibly an extra 500,000 or so climate-related deaths due to reductions in consumption of fruit and vegetables. They suggested there might be a slight reduction in overweight and obesity because of reduced food availability, but an increase in underweight and a reduction in fruit and vegetable consumption. And of course, we know that fruit and vegetables are so important for the prevention of chronic and non-communicable diseases. We also know that environmental changes of various kinds have an effect on fruit and vegetables. This is just a slide showing the effects of different environmental exposures on vegetables and legume yields undertaken by my colleague Pauline Schielbeek last year. And what she showed was that many environmental changes, like decreasing water availability, and many countries are running out of fresh water, temperature increases, ozone, which as I've said is a toxic pollutant produced by human activities in many cases, would have negative effects. Carbon dioxide does stimulate the growth of crops, and many people have said, well, that's a wonderful thing, CO2 is a great, we need more of it. Unfortunately, that's not true, because CO2 also reduces nutrient quality as well. It doesn't stimulate all crops. And overall, there's still an overall negative effect of all these environmental changes on fruit and vegetable production. And many countries, of course, are suffering from multiple challenges. It's not just climate change doesn't come in isolation. It happens against a background of multiple changes. So let's take India, for example. I just was in India a few weeks ago, and very interesting and quite worrying challenges ahead for India. They have population growth, of course. They have dietary change. I'll say a bit more about that in a moment. They have groundwater depletion. Particularly in the northwest here, in Rajasthan, they're depleting aquifers very rapidly. And they're running out of water potentially. You can't recharge them quickly enough because of low rainfall. So this really threatens the crop yields in this part of India, and also some of forces them to go deeper and deeper in the quest for fresh water. And as you do that, you can suck in all sorts of toxic substances like fluorine, for example, causing fluorosis. And then, of course, climate change on top of that. So it's multiple impacts. After years of progress, hunger is on the rise. Hunger seemed to be going down until about 2015 or so, but the last few years the number of hungry people has gone up. Maybe that's climate change. There are other factors happening as well, no doubt. There are conflict and so on, but probably there's a climate change signal in there that's contributing to this upswing in the number of undernourished people in the world. And as I've mentioned, it's not just the amount of food, of course. We do produce a lot of food in the world, but a lot of it's maldistributed. But it's also the nutrient quality of the food. And this slide shows you how carbon dioxide fertilization reduces the nutrient concentration in many plants, particularly these C3 plants, which are many of our common crops. And in particular, look at these two micronutrients here, iron, zinc. Both of micronutrients are common to have deficiencies. So this kind of reduction in nutrients could increase the number of people with micronutrient deficiency, and there's a reduction in nitrogen and obviously an increase in carbon. So changes in nutrient quantity as well as crop amounts, crop yields. We're also seeing some interesting and somewhat unexpected changes in parts of the world. Bangladesh is another country facing multiple challenges, not just climate change, but also they're damming a lot of their rivers, extracting a lot of water and so on. And work by my colleague Pauline Shielbeek and other colleagues in Bangladesh has shown that people in these coastal areas are drinking very salty water because as the sea level rises, you dam the rivers, so you reduce the fresh water flow. That increases the level of salt in the fresh water. Now, we've always assumed that it was salt in food that was important for blood pressure, but this work has also shown that if you have very high levels of salt in drinking water, it can affect blood pressure in pregnant women and also in non-pregnant people as well. And there's a seasonal relationship between the drinking water and sodium and fluctuations in blood pressure. So this again suggests a novel mechanism by which environmental change, both local and global, can affect heart disease and stroke risk. We're also beginning to be aware that mental health can be impacted on by environmental change. When you follow up people who've been exposed to floods, you find a high proportion, a high prevalence of mental ill health, particularly depression. And there's some evidence that even high temperatures themselves may increase mental distress, and there's a relationship with suicide rates in some countries. So environmental change may affect mental as well as physical health. And then, of course, there's been a big question mark about some of these big social changes. Will it affect conflict? Well, it's still quite controversial, but possibly it might do in some areas where subsistence farmers are faced with declining crop yields, and that can trigger conflict in some circumstances. And possibly migration. This is a paper looking at refugees coming into Europe and showing that there's a relationship between temperature in the source countries that these refugees come from, and making future projections about potential increase in number of asylum seekers under climate change. Obviously a lot of uncertainties there, but it's plausible that migration could increase as a result of environmental change. So can humanity adapt? Well, obviously we can adapt. Humans have been adapting to varying climate throughout their history, and undoubtedly they can adapt to some degree already, and already they probably are. Heat-related deaths are declining in some parts of the world because of increased air conditioning, better housing, and so on. But there are limits to adaptation, and there are physical limits, like the small low-lying islands. There are behavioral limits, because people want to live in the place where they've been brought up, and they like the familiar environment. And there are technological limits in terms of the cost of flood defences, which have to be upgraded depending on the level of sea level rise. So all that really tells us that we have to act, and we have to act with some degree of urgency, because we only have a few decades to act in order to reduce the risk of exceeding 2 degrees. I don't like the word warming. Increasingly warming sounds comforting, but I'm afraid it's not very comforting. It's heating, and many people are increasingly not using the word climate change, but climate disruption or even climate crisis. But there are benefits, and there is a positive story as well. And I think it's important to emphasize that you can't just go around talking to people about the doom and gloom. You have to offer a way out of all this. And we have been doing quite a lot of work, as Ralph said in his introduction, trying to articulate strategies which could create a more positive vision of how humanity can thrive in the Anthropocene, live a healthy life, maybe at lower levels of consumption, lower levels of environmental footprint, but nevertheless a high quality and healthy life. And so we've been looking at policies in a whole range of sectors. I don't have time to go into details, I'll just give a few examples really, but housing, transport, food and ag, electricity generation and healthcare. There is a slight warning here. It's also possible to get co-harms if you have badly designed policies. So remember that some governments were promoting diesel vehicles. Just a few years ago they were saying, well, we should go to diesels because diesels are more fuel efficient, less CO2 emissions. But of course diesels are also more polluting. So there are bad policies as well as good ones, but there's lots of very positive policies that you can develop and implement. So air pollution and climate change, they're two sides of the same coin, as many people have said, because many of the sources of greenhouse gases co-emit air pollutants or contribute to their formation. So that multiplies the costs arising from the current rather dangerous pathway that we're moving along, but also it's an opportunity to amplify the benefits of our actions and really to catalyze even greater actions. This is a paper that just came out a couple of weeks ago where we did using a very well-refined atmospheric chemistry model run by our colleagues in Germany, Professor Lilleveld and colleagues. We looked at what would happen if you take out the fossil fuel sources of air pollution and greenhouse gas emissions. And what we showed was that you could get about 3.5 million deaths, something of that order, per annum less by decarbonising the world economy. And if we could remove other sources like air pollution from agriculture or from burning solid fuel in houses, then we could save even more deaths, avert even more deaths. And we'd have a good chance of staying under 2 degrees. But we need to move quite quickly. So cities are going to be crucial because cities are where about 85% of the global economy is driven from, and about 3/4 of the global energy-related greenhouse gas emissions, a lot of the transport emissions and so on. And this slide is just a kind of tale of two cities, really. It shows you Atlanta in Georgia, and you can see Atlanta has a very big urban area. It houses about 5.3 million people. Barcelona also about 5 million people, but it's much, much smaller, isn't it? About 10% of the surface area. And look at the difference in the transport-related carbon emissions, 7 per capita to just over 1. And the reason for that, of course, is because if you live in Atlanta, it's difficult to walk or cycle or use public transport. You're pretty well forced to use your car. The mayor is trying to do a lot about that at the moment, improving public transport, walking and cycling. But it's a difficult thing to change once the infrastructure is in place. So designing new cities or retrofitting existing cities to make them more livable, more conducive to active travel is important. This slide just shows you sustainable travel infrastructure and uptake in different cities. So the red is car use. You can see that Melbourne, for example, it's a couple of years old, so it may be slightly out of date, but Melbourne, nearly 80% of journeys are due to cars, involve car use. In Tokyo, it's just over 10%. Many European cities are somewhere in the middle. Some of them are changing fairly quickly towards more active travel. So you can see that the green and the black are the walking and cycling. And some cities have quite a lot of journeys undertaken by walking and cycling. And some cities like Bangalore, for example, one wonders whether their patterns are going to reverse as more cars come into the economy, and that's obviously a concern. We also know that there's a relationship between commute mode and various indices of physical health. So this is just a slide showing some work by my colleagues at the London School using data from UK Biobank, about 500,000 people, where they looked at the relationship between percentage body fat in midlife and the way in which people commute. So you can see on the left here, these are the people that only use a car. And as they use increasing amounts of physical activity to commute, right up here to the people who either cycle or cycle and walk, you can see that the amount of body fat, the percentage body fat declines in a kind of fairly clear dose-response fashion, suggesting that active travel in relation to transport is an important determinant of body fat. There's also some evidence that when people become very obese, they become more dependent, of course, on fossil fuel-powered vehicles. Some work done by another of my colleagues, Anna Goodman at the school, which was a survey of about 3,500 UK adults, showed that CO2 emissions, at least transport-related CO2 emissions, were significantly higher in overweight and obese participants because they were physically disabled, they had to depend more on their car, and they tended to have larger vehicles as well. There was an interesting caveat here that those people who said they walked a lot for recreation tended to have higher carbon dioxide emissions, and the reason for that was because they often drove out of the city at weekend to go on long walks. So the act of driving out of the city itself contributed to their CO2 emissions. This is some work we did a few years ago, looking at the effects of the health effects of low carbon transport and increased active travel in London. And what we assumed was that people used lower emission vehicles and also walked and cycled like people living in Copenhagen, which has a very high patterns of walking and cycling compared with London. London's changed a bit since we did this work, so it's probably not quite the same today. But we did show substantial reductions in disease burden as a result of increased physical activity, in particular, some increase in road danger, but you can see that the benefits vastly outweighed the dangers, and the dangers can be reduced further by, of course, appropriate policies. We also did work showing how increases in physical activity from active travel could reduce the burden on the health service, and this is the cost diverted to our National Health Service for England and Wales, again making the assumption that people in urban England and Wales, which is about 85% of the population, walked and cycled like people in Copenhagen, and you can see how the costs diverted to the National Health Service take off over a 20-year period. They're not instantaneous. It takes time, for example, to reduce diabetes and some of these other conditions, particularly cancer, takes much longer. But there were benefits over time to the health system, probably amounting to about £17 billion, say over 20 billion euros over a 20-year period. Some people ask the question, can air pollution exposure negate the benefits of cycling? And this is a paper from Tainio and colleagues, not from our work, but it's an interesting paper. And what they showed was that depending on the level of air pollution, you could, after long distances or a lot of time spent cycling or walking, you might have an adverse effect. But the good news is that actually you can exercise even a very heavily polluted environment like 50 micrograms per cubic meter, which is higher than most cities, particularly all cities in Europe, North America and so on. You can cycle or walk for a long time before you reach that break-even point. So for most people, unless you're in the most polluted cities, then it's still good advice to walk and cycle. If you want to wear a mask, you can. But it's not just, of course, physical benefits, it's also mental benefits. And this slide shows you a meta-analysis of exposure to green space. Green space is important for several reasons. One is it protects biodiversity, depending on how it's looked after. Secondly, it reduces the urban heat island. Thirdly, it can modestly reduce air pollution. Fourthly, it provides, of course, a venue, an opportunity for people to exercise and to get in contact with nature. And you can see that this slide shows you the reduction in displeasurable moods and the increase in pleasurable moods from exposure to green space. Of course, it has to be accessible, it has to be safe and so on. But broadly, it's a good news story. And there's a lot of evidence, I don't have time to go into detail, about greenness and a whole range of other health outcomes. This is a study by Mike Brower and colleagues using the census cohort in Canada, when they showed a strong relationship between greenness, proximity to greenness, and mortality, particularly from cardiovascular and respiratory disease. A decrease in death rates seemed to be increased protection for those of higher income and education. May reflect the use of the space, it may reflect the safety and security and the quality of the space, we don't know. So an increasing number of city leaders have very ambitious plans for decarbonising their economy, for creating a circular, zero-waste economy where instead of waste being considered as something you throw away, waste becomes a resource which you mine for your economic well-being. And a lot of mayors have these very ambitious plans. This is the one for London. And you can see that it has a number of important qualities to it: better air quality, low noise, climate resilience, zero waste, carbon neutral, and more green space. One of the issues, of course, is that that's well after the current mayor will have left office, and it's very easy to make very ambitious proposals, but the key thing is getting on with implementing those in the near term. And then, as I come towards the end, let me just say a few words about food systems. So, the food system contributes to about 3/4 of greenhouse gas emissions, something of that order if you include land use change. And we know that the kind of food you eat also determines the environmental profile. So we know that ruminants, as I've already said, emit a lot of methane, powerful greenhouse gas. So studies like this one from Lucas Alexandrovitz, a systematic review, showed that even if we could get people eating healthy guidelines, so in other words, reduce a bit their animal product consumption, eat more fruit and vegetables, that would reduce greenhouse gas emissions, land use and water. Moving towards vegetarianism might be politically difficult to do so, but would have even greater effects. So in the UK, for example, if you could optimize the diet to meet WHO nutritional guidelines, you'd reduce the annual emissions from about 2 tons a year of CO2 equivalent to about 1.7, something like that, nearly 20% decrease, and you could increase life expectancy quite substantially. In India, it's quite a slightly different challenge. So in India, the Indian diet already has relatively low greenhouse gas emissions compared with Europe. That's India. And then you can see also that, that's Europe, that's India. But the Europeans use quite a lot of green water, so that's the water from rainfall. India uses a lot of blue water, so that's water irrigation. And as I said earlier, India suffers quite severe challenges in terms of future irrigation requirements. So if the Indian population shifted to healthy guidelines nationally, that would require an increase in fruit and vegetables, but it would really minimally increase the environmental footprints of their diet. However, if the whole Indian population moves to the affluent diets, the diets of the affluent top 20% of the population, that would result in big increases in environmental indicators. So the choices that the Indian population make about their future diet will have a big impact on the environmental factors within India in terms of their water use and the greenhouse gas emissions, as well as having, of course, major implications for their health. And then finally, of course, the Eat Lancet Commission came out a few months ago. They did this modelling of what they called a planetary health diet, which is summarised here. And this suggested that we need to eat 200 grams of fruit, 300 of vegetables, including 100 grams of dark green vegetables, 100 grams red and orange vegetables, that red meat should become very minimal consumption, and dairy also fairly modest, and we should be eating more whole grain carbohydrates. So according to their analysis, this kind of diet could prevent large numbers of deaths, perhaps 10 million or more premature adult deaths per year, and lead to a much more sustainable global food system by mid-century. And then finally, just let me say a couple of words about the health system, the healthcare system itself, because I think it's very relevant to the kind of work that you do. The healthcare system also has an environmental footprint. In the US, it's probably about 10% of greenhouse gas emissions. In the UK, it's lower, it's probably 3% or so, something of that order. And this slide's an interesting one because it slightly confounded my expectations, because the UK National Health Service did a carbon audit of where it was emitting greenhouse gases from. And I thought, well, they'll find that it's because these energy-hungry hospitals and so on. And that is true to some extent. So here's the hospital energy, here's the medical instruments and equipment, but there's also a big peak here, and that's pharmaceuticals. So pharmaceuticals are very energy hungry. Often the feedstocks and so on require a lot of energy to make, and the pharmaceutical industry is quite a major emitter of greenhouse gases. So that suggests that the more we can reduce unnecessary prescribing, promote healthy lifestyle change, we can also, as well as helping to help improve the health of the population and individual patients, we can also reduce greenhouse gas emissions. And there's a lot of initiatives now going on in the health system to help it decarbonize, using renewable energy, more efficient buildings, and also this kind of approaches. This is a hospital in Nottingham, won an award because they started sourcing their food locally, sourcing plenty of plant-based food and providing that to patients and to staff in the hospital canteen, and they were given an award for that. So there's a lot that can be done within the health system, and of course health professionals, whether they be public health professionals or healthcare professionals, also have a lot of influence in their society, and we can maybe talk about that in the discussion. They can help to promote behaviour change, which is what, as I understand it, you're about. So this is my last slide. Let me just conclude by saying we do need urgent action. And the reason that we need urgent action is really summarised in this slide. So what it shows you is if we want to keep 50% chance of keeping to 2 degrees warming, which, as I've said, is the kind of limit that many climatologists have given us, the kind of rule of thumb, if you like. We've got less than 30 years at current emission rates, so we need to cut quickly. If we want to keep to 1.5 degrees, which is what many people think we should do, particularly the small island states and those very vulnerable countries, we've only got less than 10 years. So we really need to build on the ambitions of Paris. I've said that some governments are pushing back on those ambitions and they're undermining the Paris Treaty. But the health professions then, I think, have a very important role in making the case for urgent cuts in greenhouse gas emissions, for moving towards a more sustainable economy, which will help to reduce the environmental footprint of society, but also, as I've tried to explain, also bring big health benefits for the population and for individual patients. Thank you very much indeed.
So I just wanted to say a huge thank you to Andy for setting the scene for this conference. It's a different presentation than we've had typically in the past, but I think it's a sobering one, but also you've given us lots of opportunities to think about where there are ways that we can, in a behavioural nutrition, physical activity and policy approach, there is some light at the end of the tunnel, but as you say, we have to move very quickly. So it's been a real pleasure to have you with us, and Andy will be around, and so there will be time to catch up with him as well. It's a small gift. It's not very heavy, so you can take that with you. So once again, thank you very much. So thank you all for coming to the welcome ceremony, and I feel very inspired by Andy's talk, so it's been absolutely fantastic. We do have a welcome reception, which will be up on level 2. Our folk people will be there as well, so there'll be drinks and nibbles. So this is a really good opportunity to meet and greet, and also to catch up with old friends, and an opportunity to chat and collaborate. So please take this opportunity, and we look forward to seeing you for a drink. Thank you.